Today we're going to look at finding the area of composite figures, but first we need to know what exactly is a composite figure. A composite figure is a figure that is made up of several smaller figures put together. And the easiest way to find its area is to break it into its pieces. So it, for example, could be made up of triangles and parallelograms, or it might have a rectangle and a trapezoid, something like that. So we want to break it into its parts, find the area of the parts, and then use that to find the total area. One example is if we look at this figure. When we look at this figure, there's no one formula for how we find the area of this figure, so we have to break it into parts and then find the area of the parts and find the total area from that. There's a lot of different ways you could look at this. You might look at this as just splitting it into three rectangles with one big rectangle at the bottom, that's the green one, and then two congruent rectangles kind of sticking up out of the top, that's the orange and the purple ones. You might look at it as the two congruent rectangles on the left and the right with one there in the middle. I'm going to look at that one for just a minute. If we look at this, when I look at this and I want to find the area of the whole figure, I'm going to think about this is part 1, this is part 2, and this is part 3. So I've got 3 parts there. And I'm going to look at part 1 is a rectangle, and I can find its area by doing length times width. So for this particular figure, I can see this side is 20 feet. So I've got 20 times, then when I look at the width, I need this distance. Now, looking at this figure, that distance is not given to me, so I have to look and see where can I find that distance from. Well, it would appear that this side is congruent to this side, so I would look at it and say, well, then this side must be 30 feet. So 20 times 30 feet, or 20 feet times 30 feet, is 600 square feet. So that's going to be the area of that section. The third section is the exact same size. It's congruent, so I just know that that one's 600 square feet. And then the one in the middle, when I look at that one, I can see that this distance is 32 feet. So when I do length times width for that section, I'm going to start with 32 feet times, then I need to know this part right here. Well, that measurement is not given to me, but what I do know is that the whole thing is 30 feet. And I know that because this side is congruent to that whole section, which is congruent to this whole section, which is congruent to this whole section. So that the whole distance has to be 30 feet. And I know that just this part of it is 12 feet. So that means that this part of it has to be 30 feet minus 12 feet, which is 18 feet. So then I'm going to have 32 times 18. Now all I need to do is finish working this out. And when I finish working this out, I'm going to get 576 square feet here. When I want to find the total area of the whole thing, the total area is going to be the 600 square feet plus the other 600 square feet plus 576 square feet. And when I add that all together, I'm going to get 1,776 square feet. And that's going to be the area of my figure. Now, that's not the only way I could find it. Remember, I said we could look at it as splitting it this way. I'm not going to work that out because that's essentially the same process. Find the area of each of the 3 parts and then add them together. This way is a little bit different. This way would have you making one bigger rectangle, and that particular rectangle then has an area of length times width, and our length and width in this case are 72 and 30. So our total area, this is going to be 2,160 square feet. Now notice that's the area for the whole big rectangle. I still need to go back and find the area for this section as well. And when I find the area for that section, I'm going to do 12 feet times 32 feet. And when I work that out, 12 times 32 is 384. So I'm going to get 384 square feet. Notice this time what I need to do to get the total is I need to take the big rectangle, which was the 2,160 square feet, and subtract the 384 square feet. When I do that, I'm still going to get 1,776 square feet. Let's look at a couple more examples. Now, here's another example, and you could split this figure a couple different ways. You might first look at it and think of it this way. So here's figure 1, and here's figure 2. Figure 1 is a rectangle, and clearly one of the sides is 9 centimeters. This side right here is going to be 4 centimeters, and the reason it's going to be 4 centimeters is because this whole section is 10 centimeters. This part is congruent to this part, so it's going to be 6 centimeters, and 10 centimeters minus 6 centimeters is 4 centimeters. So that has to be 4 centimeters. Now some of you are probably going, how in the world can that be 4 centimeters, but this is 2 centimeters? That looks like that side is smaller than the 2 centimeters. And you're right, it does. The lesson to learn from that is sometimes when you look at geometric drawings, the measurements kind of don't look like they make sense, but you have to go with the math of it. So mathematically speaking, it has to be 4 centimeters. So 9 times 4 is going to give me my area of that section. So it's going to be 36 square centimeters. And then for the second section, it's a rectangle, so area equals length times width. And for this one, I have a length of 6 centimeters and a width of 2 centimeters, giving me an area of 12 square centimeters. My total area then would be 36 plus 12, which is 48 square centimeters. Now, that's not the only way I can solve that problem. That's just one way to solve it. I could look at that problem, at that picture, and that figure rather, and I could separate it out a whole lots of different ways. So, for example, I might look at it and decide I see 2 trapezoids there. If I split it here, I'm going to have 2 trapezoids. Well, when I look at that, here's my first trapezoid. We know area equals base 1 plus base 2 divided by 2 times the height. So I've got base 1 is going to be 9 centimeters plus base 2. This distance has to be 7 centimeters, and it has to be 7 centimeters because we know this part is 2 centimeters. 2 centimeters plus 7 centimeters matches the 9 centimeters over there. So 9 plus 7 divided by 2 times the height is going to be this distance right here, and that distance has to be 4. We've already kind of gone over that. It has to be 4 because this whole distance is 10 and this piece is 6. So times 4 over here. So when we work that out, 9 plus 7 is 16. 16 divided by 2 is 8. 8 times 4 is 32. So I'm going to get 32 square centimeters for figure 1. Figure 2, I'm going to do area. Again, it's a trapezoid, so base 1 plus base 2 divided by 2 times the height. So base 1 in this case is going to be 10. Base 2 is going to be 6. And then I'm going to divide that by 2 and multiply it by my height, which is 2. Now really that divided by 2 and times 2 cancel, but we can work it out. 10 plus 6 is 16. 16 divided by 2 is 8, and 8 times 2 is 16. So I get 16 square centimeters. And when I go back and I add my 2 sections together, then I have 32 square centimeters plus 16 square centimeters. I'm going to get 48 square centimeters. So that's another way to do that exact same problem, and you're still going to end up with the same answer. It's a different way to do it, but you're going to end up with the same answer. So the key to this really is figuring out how can you split the figure up into shapes that you know how to find the area of, and then can you find the dimensions of those shapes.